Good morning and welcome to our first AP video this year. This one is about what is a mole. A mole is basically connected to mass, and it's connected to number of atoms and molecules, and it's used in many calculations. It's also used in formulas to determine proportions of compounds and elements and how they react. So it's probably one of the most important things in chemistry. But what is it? If you ask even a graduate chemist, they're most likely to give you a cryptic explanation or a book definition, such as a mole is 1/12 of the mass of the carbon isotope C12, blah, blah, blah. And we're going to try to explain that in a better and more efficient way. So, if you look at the periodic table, these cells that contain information about elements, they contain two main numbers. So this one is the atomic number, and that equals to the number of protons. And this is a mass number, which equals to the number of nucleons, which are protons and neutrons combined. But the mass number has another meaning, and that is that the mass number is also equal to the mass of one atom of this element. But that mass is expressed in units called atomic mass units. You can see them in different books, and even the AP curriculum, you can see them as AMU or AU or just U, and that just means atomic mass unit. So one atomic mass unit equals to the mass of one nucleon. And then since nitrogen has 14 nucleons, its mass equals to 14 atomic mass units because the electron mass is 1,800 times smaller than mass of nucleons, so it doesn't count. However, what is this U? What is this atomic mass unit? It's basically a very small mass because you cannot really express the mass of an atom in grams because you're going to end up with a number 0.0000 and 22, 23 zeros and then something. So that's just impractical to put into the periodic table. And then comes the mole. What is a mole? Since in our world, in the macro world, we cannot work with atoms. I mean, even if you take a spoonful of salt, you're going to end up with like trillions of trillions and trillions of atoms. So we work on a much bigger scale. Also, we cannot use atomic mass units in calculations just because physics was invented by the first part of physics. The physics that was invented was mechanics, and that is physics that involves grams and kilograms. So now all physics and chemistry mostly works on grams and kilograms. So you can't use this thing. You can't use atomic mass units. You have to use grams. So a mole is an amount of an element whose mass is in grams expressed by the mass number. So the mass of one mole of nitrogen is 14 grams. That's all you need to remember. And if you look at the periodic table, so the mass of one mole of hydrogen is 1 gram, 1 mole of lithium is 6.94, 1 mole of carbon is 12 grams, 1 mole of phosphorus is 30.97. So for any element, you can always find the mass of 1 mole in grams, and that just equals to the mass number. This is called a molar mass. So we can say that the molar mass of nitrogen is 14 grams per mole. So the unit is grams per mole because it means that many grams per each mole, per 1 mole. Uh, Also, it's important to know that when you're getting these questions, you might get different wordings, such as this. So, mass of one atom of oxygen is 16 atomic mass units, not 16 grams, it's one atom. But mass of 1 mole of oxygen is 16 grams. And it's good to hear, remember that the way we say 1 mole, the way we denote that is we put a large one, a capital one, in front of an element or compound that we're working with. That means it's 1 mole. So basically, 1N means 1 mole, and it has a mass of 14, right? 5N is 5 moles, and the mass of that is 5 times the mass of 1 mole, right? 1CO, when you have compounds like this, you have to add the masses. So 1CO has a mass of 12 plus 16, right? And you can see where this is going. So when you put whatever you put in front is the number of moles, and that multiplies everything that you add and multiply to get the mass of that compound. Now, uh, we need to learn how to convert moles into mass and vice versa, and also how to use Avogadro's number, that is to calculate how many protons, how many molecules and atoms are in different number of moles and grams. But to use that in the AP curriculum, you will see they use unit conversion. That's a good way. It's a pretty good way. However, I recommend, especially if you're a beginner, to use proportions. I will show you. I won't show you how to use unit conversions. We're going to do that. We're going to learn that gradually as we go through the course. But I will teach you how to use formulas and how to use proportions. So first, let's see how to use a formula in real settings. So what is the mass of 0.35 moles of carbon? Remember, you can always check the periodic table and see that 1 mole of carbon is 12 grams, right? So this is the formula for molar mass. Molar mass equals mass divided by number of moles, and molar mass is in grams per mole. So in the periodic table, you will find that the molar mass of carbon is 12 grams per mole, right? And you have in the question itself that there are 0.35 moles of this, and you can simply calculate the mass from that, right? Uh, there is another way, and that is proportions. I really recommend you use proportions for different things. And the reason is proportions are not used only for this specific conversion. You can use them for anything. Let me show you how. So, a proportion is basically just an if and then statement. So, if 1 mole of carbon weighs 12 grams, because you know that from the periodic table, then 0.35 moles of carbon, which is what the question is asking, weigh how many grams? When you do that, you just multiply the inner numbers and the outer numbers, and you get this. And then from this, you can simply calculate your number, and you can just cancel the moles out. You can see the gram is the unit, but you already know the gram is the unit here. Why choose proportions? Because proportions only have one rule. Whatever is on the left side of these on the equal sign. So if you put moles here, here also the unit has to be a mole. If you put grams here, it has to be gram here. If you put, I don't know, apples here, then apples got to be here too. So the units in the first part of this equation and in the second part on both sides of the equal sign, they have to be the same unit. As long as you do that, you can use this to convert anything into anything. So this doesn't just work. So if you use this formula, this only works for converting moles and grams and molar mass, right? But this can be used for anything: volume, number of atoms, number of molecules. And so I recommend you learn proportions because they're really the safest way to really do this. So you really cannot make a mistake if you respect their one simple rule. Now, here's an example. So 45 grams of this, how many moles? First, I have to find out how much is 1 mole of this. And if you look at the periodic table, sulfur is 32 grams per mole, oxygen is 16. When you add these together, remember you have 3 oxygens. This 3 means you have got 3 oxygens. That's 80 grams per mole. So you just go 1 mole of this weighs 80 grams per mole, and then how many moles weigh 45? You can just calculate in the same way. Now, Avogadro's number is another thing that is very often used in AP chemistry. So Avogadro's number is 6.02 times 10 to the 23, 10 to the power 23. I'm not going to repeat this again. I'm just going to call it Avogadro's number from now on. Avogadro's number is a constant, and the rule is this: 1 mole of anything always has Avogadro's number of particles. And when we say particles, you can mean atoms or molecules. So if I write 1 mole of oxygen like this is an atom of oxygen, right? I have in there Avogadro's number of atoms. But if I write 1O2, that means I've got 1 mole of oxygen molecule. Then I got Avogadro's number of molecules. If I got 2 moles of O, then I just multiply 2 with the Avogadro's number, and so on and so forth. Now, you will see how to use proportions to convert easily between these three things. Avogadro's number, actually number of particles, grams, and moles. So this is the first example. 2.5 times 10 to the power 22 is how many moles of NO? They didn't write here that this is molecules, but you can see this is a molecule. So this many molecules is how many moles? Well, I know 1 mole is Avogadro's number, right? Then X moles is this much. And I just multiply the outer and equalize that with the inner numbers, and I can just calculate this with a proportion very, very easily. Now, there are two ways to use the proportions, as you can see here. This is the slower way. Let me move my head. This is the slower way and the faster way. So check this out. I here have to calculate how many molecules I got in 33 grams of CO. So what you do here is first figure out how many moles is that. So 1 mole of CO is 28 grams, which is what you can calculate from here. Then X moles is 33 grams, and then you calculate the number of moles. Now, after that, you can just say 1 mole is Avogadro's number, but this many moles is how many. Actually, it should be here. It should be molecules, sorry, not mole, right? So, and then you can just calculate this. However, I recommend you go straight to this. You guys are way better at math and this stuff than me. So look at this. 28 grams is 1 mole already. So I say 28 grams of this is Avogadro's number of particle because both are 1 mole. So we can just equalize that. And then 33 grams is how many molecules, right? And then I shorten this. You can see, you can stop this and think about it. You can just shorten it. You don't have to do the whole thing. Let me check what's next. So yeah, a little reminder here. You always know, you always have two pieces of information. Number one piece, Avogadro's number is always the same. And 1 mole always has Avogadro's number of molecules or atoms, depending on what it is. And the second thing, you always know the mass of 1 mole because you have got the periodic table and you can just read the molar mass from here. Nobody is ever going to take that away from you. So always remember you got these two pieces of information. And remember that you got, excuse me, that you can use the proportions if you're not sure how to do something because they're never going to lie to you. Now, from this part of the video until the end of the video, we're just practicing. So those of you who are confident you can do the quizzes, just go do the quizzes. Other than that, if not, just stay here and we can do some practice. Take a look at this. You can pause the video, try to solve it, and then I'll show you how to do it. Yeah. So I need the mass of this many moles. So I'm going to do this with one proportion. So again, the first step is always find the molar mass of this whole thing. It's 28 grams per mole. So 28 grams is Avogadro's number of molecules. X grams, how many grams is this many molecules? And just solve it. Easy peasy. How many molecules of 15 grams of CH4? A very similar case. Again, try to solve it. And obviously I didn't put that solution. Just use it as practice. What has more oxygen by mass? 1 gram of LiO or 1 gram of CO? I put this in on purpose because this is different, a different type of question. So the thing is, let me just give you the solution so I can explain. So if you check the periodic table, you will see the molar mass of lithium is 7 grams and molar mass of oxygen is 16 and carbon is 12. So you can see that in this one here. Mass proportion of oxygen to lithium is 1 to 2. Actually, more than 1 to 2, right? So if I got 1 gram of this substance, it's likely that not likely, for sure, I'm going to have double the oxygen compared to lithium, right? So it's going to be like, I don't know, 70-30 oxygen to lithium, right? While here, you can see that in 1 mole, they're almost 1 to 1. So on 1 gram of this, I'm gonna have, I don't know, my a bit more like 60 something percent of oxygen. So basically, by mass, this one will always have to have more oxygen if the masses are equal, and or if the moles are equal as well. Now the thing is, you could calculate this. This is easy to calculate. However, when they give you questions like this, these are mostly in multiple choice. You don't want to calculate. You want to go through this quickly because you have 1.5 minutes per multiple choice question. You want to guess. Even if you're wrong 1 out of 20 times, it doesn't matter. Always try to figure it out without calculating. And if you can't, then you calculate. This one also has something different. So, how many O atoms are in 10 grams of N2O2? The thing is here, 1 mole of N2O2 is made out of 2 moles of atomic oxygen and 2 moles of atomic nitrogen, right? So when I calculate how many atoms, I can calculate how many atoms if I know how many moles of oxygen. So the first thing I'll do, I will find the molar mass of N2O2, and then I'll say 1 mole 60 grams, X moles are 10, and I will calculate I have this many moles of N2O2. However, oxygen is double because each mole of N2O2 will give me 2 oxygen moles, right? So I actually have this much oxygen. And then I can just use Avogadro's number. 1 to Avogadro's number is 0.34 to X. Just calculate. Pretty easy. This one is also kind of different because it involves density. Density is something that they will give you in the appendix. But you don't have to use the appendix because you have units here. Grams per mole, which means density equals what? Mass divided by volume, because the unit is gram per milliliter, right? And you can see here how this is done. So rho is basically is density, and rho equals m divided by v, right? So I just gotta find. So I have density. They gave me density, so I've got this. They want me to calculate v, but I don't have mass. But I have moles, and I know it's oxygen, so it's easy to calculate the mass. 1 mole is 32 grams, and 0.5 moles is how many? So I got 16 grams. I put this into the equation, and I'm done. So please try to practice these, and let me know if you can't do it or you have any problems. Contact me through the app. Good luck. See you soon.